Now we study the next important rule called as cosine rule. Now it states that in any triangle ABC, we have a square equal to b square plus c square minus 2bc cos a. B square is equal to c square plus a square minus 2ca cos b, and c square is equal to a square plus b square minus 2ab cos c. So as we can see, the three statements have a very similar pattern and that can be remembered easily. Now let us see the proof of the cosine rule. Now to prove the cosine rule, we orient the triangle ABC in such a way that one of the vertex is at origin and the other vertex lies on the positive direction of x-axis. So here we are considering vertex B at the origin and vertex C is on the positive side of x-axis. So with the usual notations, sides A, B and C are shown. Alright. Now coordinates of point C can be easily written as a, 0 because the length BC is nothing but A, and since angle B is already shown, coordinates of point A can be written as C cos B, C sin B, using the conversion from rectangular coordinates to polar coordinates. Now we write the side AC in two different ways. First way is that side AC is nothing but small b, right? On the other hand, side AC can be written by using the distance formula between points A and C. So therefore we can write b square, that is nothing but AC square, is equal to, we write the distance formula now, that is C cos B minus A the whole square plus C sin B minus 0 the whole square. Correct. So therefore we get b square is equal to c square cos square b minus 2ca cos b plus a square plus c square sin square b. So therefore we have b square is equal to, now if we club the terms c square cos square b and c square sin square b, c square comes common and cos square b plus sin square b gives us 1. So therefore we have c square plus the remaining terms, that is a square minus the last term 2ca into cos b. So therefore in this way this is nothing but the statement of cosine rule which has been proven. So similarly, by taking the other two sides as the base on x-axis as shown here, we can easily prove the remaining two forms of the cosine rule, which are nothing but c square is equal to a square plus b square minus 2ab into cos c, and lastly a square is equal to c square plus b square or b square plus c square minus 2bc cos a. This is the cosine rule. Now let's go ahead and see how we can state the cosine rule in a different format. That is, if we just rearrange the terms, we get cos A equal to b square plus c square minus a square upon 2bc, and similarly we get the remaining two statements also. Now how does this come? Now we know that originally one of the statements of cosine rule is a square is equal to b square plus c square minus 2bc cos a. Correct? So therefore let us bring the negative term here and a square on the other side. So therefore we get 2bc into cos a is equal to b square plus c square minus a square. And now dividing both sides by 2bc, we get cos A is equal to B square plus C square minus A square upon 2BC, which is nothing but the required format. So it's really not a new rule or new theorem, it's just the cosine rule written in a different manner, which is often useful. That is, the moment we spot cos A, cos B or cos C, that can be converted into this expression which involves completely the sides or the lengths of sides of the triangle. So let us go ahead and see one of the examples based on cosine rule. With usual notations, show that 2 into bracket BC cos A plus AC cos B plus AB cos C is equal to A square plus B square plus C square. Right. So now let us start off with LHS. We can open the bracket and write 2BC cos A plus 2AC cos B plus 2AB cos C. Now we just saw that the statement of cosine rule can be rearranged. So 2BC cos A can be written as B square plus C square minus A square. Similarly, 2AC cos B can be written as A square plus C square minus B square. And lastly, 2AB cos C can be written as A square plus B square minus C square. So therefore, when we add all the terms, we can see that A square gets cancelled, then B square will also get cancelled and C square also gets cancelled. So we are left with A square plus B square plus C square, which is nothing but the required right hand side. So that completes the proof.